Good afternoon, everyone. Today we're going to do a video on the special values, i.e. the most important values that you're going to see again and again and again on the unit circle. So, to start things off, obviously we have our 1, 1, negative 1, negative 1 values that are important to know. Those are kind of easier to get off the bat, but let's list those to make sure we have kind of a starting point. So, again, we always measure our theta from the positive x-axis, and so we have that sine of 0 is equal to 0 because our sine corresponds to our y coordinate, okay? So always remembering that whenever we look at points on the unit circle in relation to the angle theta that is measured from the positive x-axis, the coordinates at any point P on the unit circle, let's say x comma y, can be mapped to cos of theta, comma sine of theta, okay? And that means that whenever we're looking for specific values, doing calculations, and actually using those values to evaluate different expressions, cos theta always corresponds to the x coordinate, and sine theta similarly always corresponds to the y coordinate. It's something very, very helpful to keep in mind as we work our way through the 4 quadrants of our unit circle, okay? So if we can learn the special values in the first quadrant and we keep this relationship in mind, getting the other 3 quadrants becomes a simple exercise of remembering the sign, the positive and the negative, okay? And that's really easy to do if you have a visual sense in your mind of how the unit circle tracks along the 360 degrees and how cos and sine relate to the x and y coordinates, okay? So the first one is we have sine of 0 is equal to 0 and cos of 0 is equal to 1, okay? That makes sense because at 0 degrees, we're right smack dab on the positive x-axis. The y coordinate of this point would be 0. Y is sine theta, y is 0, sine theta is 0. And similarly, cos theta is x, so the x coordinate here would be 1. And x is your cos theta, and so cos of 0 is equal to 1, okay? And then we can track through the unit circle. We have 90 degrees, and so we have cos of 90 degrees is equal to 0, and similarly, sine of 90 is equal to 1. Really just swapping the values, right? Sine is 0, cos is 1, sine is 1, cos is 0, okay? Next, we can go to the other side of our unit circle into the negative x direction. So here, sine, the y coordinate, is still going to be 0, but now cos, the x coordinate, is going to be over in the negatives, negative 1. And so sine of 180 is still equal to 0, because the y coordinate at this point would still be 0. And we have cos of 180 is equal to negative 1. Okay, and lastly, I'm sure you've seen this before, we have cos of 270 is equal to 0, because at 270 we're right on the y-axis, so the x coordinate is 0, right? And sine of 270, now our y coordinate down here is at a minimum, and so we get the smallest value possible for the sine at negative 1, okay? Now those are, again, values that you probably learned fairly quickly. But I hope this relationship between sine and cos and x and y really kind of consolidates in your head, and then you now have more visual sense of how they track around the unit circle. So you're not ever relying on your memorization skills, but rather on a simple enough understanding of how the unit circle actually works. Now, the other special values are 30, 45, and 60 degrees in the first quadrant. And so let's take the time to look at those specifically. So we have 30 degrees around here, we have 45 degrees around here, and we have 60 degrees around here, okay? Now, let's go through this. First off, let's start with 30. So at 30 degrees, you'll notice that we're further along in x than we are in y, right? We're further along in the x direction than we've gone upwards. And so, since cos of theta is x, and sine of theta is y, cos should be bigger than sine at this point. We can see that visually because the x coordinate has to be greater than the y coordinate. And so the cos of theta has to be greater than sine of theta. It's the only way that this makes sense. And we do see that that is the case. So we have that sine of 30 is equal to 1/2, and cos of 30 is root 3 over 2. Okay? Next up, we get 45 degrees. Sine of 45, cos of 45. Okay? This is another very important value that we see so often in trigonometry. So at 45 degrees is exactly the midpoint or the halfway mark of 0 degrees and 90 degrees. At 0 degrees, we're traveling completely in x and not at all in y. Conversely, at 90 degrees, we've traveled only in y and not at all in x. 45 degrees is the perfect middle of those two 0 and 90 degree points, okay? It's the perfect balance of the two. And so at 45 degrees, we should see that the x and the y coordinates are exactly the same because we travel the same distance horizontally as we do vertically. And so sine and cos should therefore also be the same value. And that is what we find. We get that sine of 45 is root 2 over 2. And likewise, we get cos of 45 is also root 2 over 2. Okay? And now the only other special value that we find in our first quadrant, where all the values are positive, is at 60 degrees. And if you notice, 30 degrees from the positive x-axis can have its analogous twin, let's say, if we go 30 degrees down from the positive y-axis. Because if we go 30 degrees down from the positive y-axis, we end up exactly at 60 degrees. So what 30 degrees is in the x direction is kind of analogous to what 60 degrees is in the y direction, okay? The same way that we argue that 30 degrees goes further in x than it does in y, 60 degrees goes further in y than it does in x. And so we actually see the values of the x and the y coordinates, and therefore the values of the sine and the cos be perfectly mirrored, perfectly reversed. And so for sine 30, we had 1/2, and for cos 30, we had root 3 over 2. For 60 degrees, because again, 60 degrees is simply 30 degrees down from the positive y-axis, we simply get these two values reversed. And so we get that the sine of 60 is root 3 over 2, and we get that the cos of 60 is 1/2. And there we have it. These are really the only special values we have to commit to memory, and they are worth committing to memory. They're going to make your problem-solving skills so much more efficient. They'll make your studying of other more complicated trigonometric ideas, problems, concepts so much more efficient and easier to make deep connections with if you commit these values to memory, because you're going to notice patterns faster and easier and more efficiently, and everything will go along in a much more smoother fashion. If you take the time to commit these values to memory, these are 100% wholeheartedly worth taking the time to commit to memory. It doesn't take that long. Sine of 45, we have the exact same value for both, root 2 over 2. Sine of 30 is 1/2. Cos of 30 is root 3 over 2. And we swap them for 60. Okay, that's it. It's really only 3 values. And if you really look at it, if you look at the 3 values that we have, because we only have 3 values, we have 1 over 2, we have root 2 over 2, and then we have root 3 over 2. And if you want to find a bit more satisfying pattern between those 3 values, so that your brain might remember a bit easier, you might notice that 1 is really the same as root 1. And the reason I take the time to mention that is because now, if we look at our 3 values, we have root 1 over 2, which is just 1 over 2, but to kind of see a pattern emerge, we can look at it as root 1 over 2, root 2 over 2, and root 3 over 2. That's it. Those are the only 3 special values that we really have to commit to memory, okay? Because if we understand this relationship between sine theta and y, and cos theta and x coordinates, then the values that we find in the first quadrant are simply found in all the other 3 quadrants, simply with different signs, okay? So for example, 30 degrees from the positive x-axis, if we look at its mirror image on the other side of the y-axis, namely, if we go 30 degrees from the negative x-axis, well, a straight line has 180 degrees, and so that means that if we go 30 degrees up from the negative x-axis, then we're simply at 180 minus 30, which would be 150 degrees, okay? But if you look at 30 degrees and the point on the unit circle at 150 degrees, right, the y value is exactly the same. They're just as far from the positive, they're just as far from the x-axis as one another, and so their y coordinates are exactly the same. And their y coordinates are sine theta. And we see exactly that. We get that sine of 30 is equal to 1/2, and so we also get that sine of 150 is equal to 1/2. Because you see that at 30 and 150, the y coordinate is exactly the same, right? I can make a dashed line and see that they have the exact same y value. And so they have the exact same value for sine theta. The only difference is now the cos theta, the x coordinate, is simply in the negative region of the x-axis. But it's the same magnitude, it's the same distance from the y-axis, right? But now it's in the negative region, and so since we had that cos of 30 was √3/2, we simply get that cosine of 150 is negative √3/2. That's it. So you don't have to memorize cos of 150 and sine of 150. All you have to know is these values. And then everywhere else around the unit circle can be easily remembered or easily found, easily discovered, easily, however you want to say it, by simply remembering these two relationships, right? Cos of theta is going to be positive in quadrants 1 and 4 because cos theta is the x coordinate and x's are positive on this side of the y-axis. And conversely, they're going to be negative on the left side of the y-axis, which are quadrants 2 and 3. So cos of theta is negative on this side, positive on this side. Sine theta correlates to the y-coordinate, and so you'll see that sine values are positive in quadrants 1 and 2. So above the x-axis, sine theta, y, is positive. And of course, in quadrants 3 and 4, below the x-axis, our sine theta values will be negative. They're going to be the exact same values in magnitude as the 6 values we looked at here. We just have to be careful of the negatives, okay? So I hope this was helpful. I hope you do take the time. You can even pause on the screen or you can look, worksheets, different images, different screens, different photos on Google, but you can also pause the screen on this kind of set of values that we have drawn up here. Take the time to commit these 6 values to memory. Just for the pattern recognition element of it, I'll put √1/2, so your brain remembers √1/2, √2/2, √3/2, in whatever fashion you choose to put it in your brain. Again, sine theta is y, cos theta is x, and the rest, I think if you commit this memory and you understand this relationship, everything else just falls into place and you don't have to ever feel the pressure of having to memorize all these values, because you'll be able to get them whatever situation you're in, whatever the situation calls for, you'll be able to think about what the exact values you need actually are. So I hope this was helpful. I hope you got something out of this. If you have any questions, comments, suggestions, please let me know. Again, I'll finish this off. Not really any of you feeling frustrated. If you guys have any suggestions for future videos, please do let me know. And thanks for watching.